In this video, we are going to learn how to solve a system of equations involving conic sections. When I say conic sections, we're talking about circles, parabolas, hyperbolas, ellipses. But in this particular video, we are going to be finding the intersection of a line and a circle. So you're going to be given the equation of a circle and the equation of a line. And we're going to use substitution this time around to find the 2 points where the circle and the line meet, the 2 points they have in common, or you could say they're common solutions. Well, for the sake of completeness, I said 2 solutions. But when you have a circle and a line, there are actually 3 possibilities, aren't there? The line could pass through the circle like this, and you'd have your 2 solutions. But is there a way that we could have only 1 solution? Sure. What if the line was a tangent, meaning it just touched the circle at one point? So it's possible that we could solve our system and find only 1 solution. Is it possible that there could be no solution? Is that possible? Sure, the line and the circle could miss each other completely. And so if you had the equation of a line like this and a circle like that, you would find there would be no solution. So we'll have to watch out for those 3 possibilities. Alright, take a look at problem number 1. You can tell that the first equation is the equation of a line, because nothing is squared. It's like y equals mx plus b. The second equation is your circle. You can tell that because both variables are squared. Now we're going to solve the system in 2 methods. We'll solve it algebraically by doing substitution. But then we will verify those solutions by graphing the line, graphing the circle, and seeing do they in fact meet at the points that we find. Alright, so first let's solve the system algebraically. I'm going to use substitution. When I do substitution, I like to write the equations side by side. So I'm going to write y equals 3x minus 5 over here. And then I'm going to write my x squared plus y squared is equal to 25. Now the first step is to get one variable by itself. And this has already been done because the y is already by itself. Y equals 3x minus 5. So of course what you can do with that is you can take what y is equal to and substitute that for y in the other equation. So this is going to become x squared plus, so here would have been y squared is equal to 25. But we will substitute in for y our 3x minus 5 from right there. So now this equation only has x's. So we should be able to solve it for x if we're careful. So over here, the 3x minus 5 squared can be thought of as 3x minus 5 times 3x minus 5. Alright, in the meantime we have this x squared to bring down and the equals 25. Let's go ahead and do this pink part first. If we want to multiply this out, we have to do a double distributive property. So I'm going to take this 3x and I'm going to multiply it by both of these things. Alright, if I do that, 3x times 3x is 9x squared. Alright, and then I'm going to take the negative 5. Wait, I didn't finish. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Then we do the negative 5 times 3x and get another negative 15x, and negative 5 times negative 5 is positive 25. So a double distributive property. we can bring down the x squared and we can bring down the 25. So now let's combine like terms and do a couple other things. So we can go ahead and put this together. Okay, x squared plus 9x squared is going to give us 10x squared. We can put this together. Negative 15x and negative 15x, that's negative 30x. And we can also go ahead and subtract 25 from both sides. Alright, so this is going to actually make 0 over here. Okay, so that's what we have at this point. We have 10x squared minus 30x equals 0. So somehow we have to solve this. When I see I have x squared and x in the same equation, it's going to be all about factoring. But first I'm noticing that both of these coefficients are divisible by the same thing. So let's make the numbers smaller. I'm going to divide everything by 10 because I can. So let's divide everything by 10. So I can divide by 10 here, divide by 10 here, and even divide by 10 here. Got to divide everything by 10. So that's going to leave me x squared minus 3x is equal to 0, because 0 divided by 10 is still 0. Okay, now I still need to factor this. There is a common factor here. Both of these terms have x in them. So what I will do when I have a common factor is I will pull out that common factor, which is just x, and then I'll ask myself what's going to be left inside. And you can do this using common sense, sort of saying to yourself, okay, x times x, if I did the distributive property, would give me x squared. And then x times 3, if I did the distributive property, would give me 3x. So I'd have this. Another way to think about it is division. Once you see the common factor as x, to know what goes inside, you divide. So x squared divided by x will just leave x, and here these x's will cancel and just leave negative 3. So either way you want to look at it. So once you have this factored, you're going to have two solutions by setting each part of this equal to 0. So it's going to be like this. You can set the x itself equal to 0, and that gives you one solution here. But then you can set the x minus 3 equal to 0. And to solve this, you need to add 3 on both sides. So that's going to give you x equals 3. Okay, so we have these two x values. But what we are looking for are points, ordered pairs. Okay, we need an x and a y. Remember our line that's intersecting the circle? These points are ordered pairs. So this is like x1, y1, and this will be an x2 and a y2. Alright, so we need an x and a y. So we have some x's, how will we get the y's? Well, that's what this other equation up here is for. Now, I like to look at this as a table of values. Alright, I like to look at it this way. Okay, x's and y's. So we just found two x values. So we have an x value of 0 and we have an x value of 3. What we need are the y values that will go with these x values. So to do that, we can just plug these in, okay? Because what we know is that y equals 3x minus 5. So if I have x is 0, then that's 3 times 0 minus 5. Well, 3 times 0 is just 0, and then so 0 minus 5 is negative 5. Okay, if x is 3, then this becomes 3 times 3 minus 5. Okay, 3 times 3 is 9, and 9 minus 5 is 4. Okay, so that's why in the end my two solutions are 0 comma negative 5 and 3 comma 4. So these should be the two intersection points between my line and my circle. So let's verify that graphically. Okay, so let's start with a line. We know how to graph a line, especially when it's in slope-intercept form, y equals mx plus b. Alright, because we know that this 3 represents the slope, and this negative 5 represents the y-intercept. So start with the y-intercept of negative 5. So y-intercept of negative 5 means the line crosses the y-axis at negative 5. So we'll have this point right here. Then the slope of 3. This is like 3 over 1. So we can use that slope, rise over run, to get more points. So 3 over 1, that means like up 3 over 1, up 3 over 1. Rise over run, up 3 over 1. We'll just keep going until we run out of graph paper. And we can continue the pattern to the left. Okay, so these dots show us where the line is. So that's what our line looks like. Now let's take a look at the circle. So the circle, you see that it's just x squared and y squared. So right away you should be thinking about what the center is. Alright, so hopefully you can see that this circle has center 0 comma 0, because it's just x squared and y squared. It's not x plus 5 and y minus 3 or something like that. And then the radius, because this is r squared, that means the radius is 5. So this is our circle. So let's graph a circle that has center 0, 0 and radius 5. Alright, so if my center is here at 0 comma 0 and if the radius is 5, that means I should be able to go up 5, down 5, right 5, and left 5. So I'm just going to draw a circle through these points. If you have a compass, you can make it perfectly. Otherwise, you have to go bootleg with it. Okay, so there's my circle. So the intersection between these two, well, the intersections are here and here. Okay, so this is the point 0 comma negative 5, and this is the point 3 comma 4. So let's see how that matches up with what we found algebraically. Oh, look at that, 0, negative 5, 3 comma 4. So that is how you solve a system of equations involving a conic section, like a circle, and a line. That's how you find the intersection of a line and a circle. Algebraically, using substitution, and graphically. Just graph them both and see where they intersect. Here endeth the lesson.